Everyone, coming to the problem given, the problem is frequency in a limited array. Yeah, let's just see what has given in it. Or in the, yeah, as we can see in the problem, what I have understood is like they'll be giving an array of numbers which will be containing from 1 to n, and we have to return an array that will be contain the frequency of the numbers at the particular index mentioned. Uh, and now what's the thought process is like I will be iterating through the array for the whole loop, and I will be incrementing the number I found there. I will be incrementing in the resultant array. So writing the code, yeah, creating a void function, and its parameters and its arguments are like int array, like the original array, and the length of the array I will be taking, or I can directly calculate that also. And I will be maintaining the result array. It will be also getting from the main function, and then I will be iterating through the array. In that array, I'll be making the result of all the things as 0, as is the starting point. Now the result of the every element I will be noting that will be 0, as is the start thing. Result of I is equal to 0. Then after, now I will be iterating through the array and increasing the frequency for whichever the element I found out. For int I equal to 0, I less than n, I plus plus. I will be incrementing the result. Result of array of I minus 1. This minus 1 is because due to in question is mentioned as one based array, so I will be subtracting 1 from the element I have seen in that array. Now writing the main function, the test case here. Let's take the example given in the question. It is 2 comma 3 comma 2 comma 3 comma 5. Yeah, then after I have to give the parameter the size also, right? So initializing a integer n for the size of the array, size of array divided by size of array of 0. Yeah, then after I am initializing a result vector for that, real vector for that of size n, and I will be calling the function, and the function takes the parameters the original array and the size of the array and the result. Now I will be printing the result. For int I equal to 0, I less than n, I plus plus. Each element I will be printing the result. Enter %d comma result of I. Yeah, now I will be running the code. As you can see, for this test case the output should be 02201, and we have got it as the output is matching. Now for this, if you can see, we have constructed an array of size n for the first O result. So the space complexity will be O of n, and the time complexity we are running the loop for 0 to n minus 1 in the original array, so it would be also O of n. So now to optimize this code, we will be going to the like say O1 space complexity solution. For that, what I will be doing is like Yeah, the main problem is like here we should be replacing the array in place, so I will be not initializing a separate result vector for this, so I will be removing this result vector for this. So in place the array we will be modifying the result. So yeah, this is the thing, and here this not need a parameter for end result here, as we are modifying that in the in place. And what I will be doing here is I will be decrementing the each number, so that I can move from 0 based index to the 1 based index now. Sorry, as mentioned it's the 1 based index, so I will be moving to a 0 based index now, array of I minus minus. Yeah, then after what I will be doing is that I will be incrementing the array with the size of the array whichever the index I have found. Let's say for example here, if you can see for the first elements, for the first 0th index it is 2, right? So I will be like decrementing that by, as I have decremented it by 1, so it would be 1. So I will be incrementing array of 1 means that index element with the length of that element, so that what happens is like it will be noting that this element is repeated one time. If you add an particular size of the array to the particular element, then you will be noting like that it has occurred one time, like that the logic works. And here I am writing the code is of array I percentage n, like it's a modulo thing we will be doing here, is a modulo thing. Then I will be incrementing this with the size of the array. Yeah, then after I will be again iterating through the array, and I will be dividing with the length of the array, and I will be getting the coefficient, and I will be storing the coefficient there, because it would be result in how many times the array how many times the element has been repeated in the particular index. So for int I is equal to 0, I less than n, then after I plus plus, then it's like array of I is equal to array of I divided by n. Yeah, this is the thing in place, as I have been replacing that in place. Now just I'll run the code. Yeah, we can see that we have got obtained the same result. Okay.